Greetings, math fans. All right, so this is day 2 of chapter 3, and we're going to just kind of cover a little bit about functions. Okay, so we're going to talk first of all, what is a function? How do you recognize a function? How do you recognize if something is not a function? And then we're going to actually show you some functions and plug some numbers in. Okay, so first of all, there are 2 ways to determine if you have a function. So we're going to talk about both things. We're talking about points. We're going to talk about graphs. Okay, so again, our topic today is functions. Okay, so here's the deal. It's really easy to identify if points represent a function. Here's the deal. X values, and you guys know when I talk about X values, that's my X comma Y. Okay, so my X values can't repeat. Okay? That's how you determine if something is a function. So X values can't repeat, then the points represent a function. That's basically what it is. So this is actually really simple. If I give you, 5 comma 3 and 4 comma 2 and 3 comma 1 and 2 comma 0, I give you a bunch of numbers like this, a bunch of coordinates like this. What you're going to do again is you're going to look at just the X values, and if one of those repeats, any one repeats, it is not a function. Okay, in this case here, these are all different. So we say it is a function. Okay? It's that simple. So we'll do graphs in a second here, but let me give you a couple more examples here. Right? So if I give you something like 5 comma 8 and 3 comma 2 and 7 comma 6 and 9 comma 1 and 3 comma 12. Right, so does this represent a function? You would look at all your X values, and if any one of them repeats, it is not a function. So right away you should go, ha! There's a repeat right there. Okay, so this is not a function because of the repeats. Okay, that's it. It's that simple. All right, but again, it's just X values. Okay, so if I give you something like 2 comma 5 and 3 comma 6 and 4 comma 5 and 5 comma 6, okay, so you notice that I have, look at those Y values, right? Yeah, you're like, hey, look at that, there's repeats. Hey, look at those are repeated too. It doesn't matter. As long as this and this and this and this, as long as the X values are not repeating, it is a function. Okay, the Y values can repeat. You could have every single Y value the same, but if all the X values are different, it is not a function. Okay, so that's how you do it with points. You look at the X values. I cannot stress that enough. X values only. Okay, very important. All right, so let's look at some graphs now. Basically, so this will take graphs. Basically, if you have a graph that looks like this, let's just actually talk about, remember how we said if X values repeat? So watch this. What if I give you a graph like this? I give you a graph like this. Okay, and let me plot, if I look at this point right here, and I look at this point right here. Okay, if I would ask you what point that is, you would say, oh, that's 2 comma 3. And if I say, what is this point, you would say 2 comma negative 3. So if I gave you these points, I know what you should say. You say, Mr. Curvis, this is not a function because the X values repeat. And I would say, you're right, so this is not a function. Now, as opposed to plotting points, I want you guys to understand we're going to do something called the vertical line test. Vertical line test. Okay, and remember, vertical line is up and down. Okay, you should remember that. Because remember, if you look, this is a horizontal line. The horizontal line means you're looking at the horizon, right, left to right, so it's side to side, and vertical is up and down. Okay, so that's a vertical line. Let me get rid of this one so we don't get confused. Okay, so here's the deal. If you can draw a vertical line, I'll write this out here on the side. So if any vertical line can be drawn and hit the graph in more than one place, it is not a function. That's what the vertical line test. So watch. I'm gonna take a vertical line, just what those points I drew. I'm gonna draw a line, and right away you should say, "Oh, Mr. Curvis, you hit it here and here. You hit it in two places." You would say this is not a function. Not a function. So you don't even have to plot points. I mean, this is okay, but you don't even have to plot points. Literally, if you draw a vertical line and it hits it in more than one place on any part of the graph, it is not a function. Okay, so let's do a couple more examples here. Okay, so if I give you a graph and the graph looked like this, well, right away, if I try to draw some vertical lines here. So here's a vertical line. Oh, I hit it one spot. Oh, I hit it one spot. Oh, I hit it one spot. Oh, I hit it one. There is no line that I could draw where I'm going to hit it more than one spot. So I would say this is a function. Okay. Let me give you another example. So if I do kind of like this, that's my function. So you're going to draw a vertical line, and you're going to say, well, again, look at it right here. If I draw a vertical line right here, look how many spots it hits. One vertical line hits it in actually 3 spots. It just has to hit it in more than one, but it actually hits it in 3. This is not a function. Okay? If it hits it in more than one spot, drawing a vertical line is not a function. Okay, so let's look at a couple more here. So if I just even like a parabola like this, right? This is a function. I can't hit it in more than one spot. 1, 1, 1, every time is one spot. Okay? If I do a problem that looks like this, like that, okay, then you should say, oh, yep, right there, there and there. So this is not a function. This is, so not function. And the one I did on the left here is a function. Okay? Really, really, really simple to identify that. Okay, so that is how you identify using points and using a graph if it is a function. Okay, so let's actually talk about what a function looks like in algebra form here. Okay, so here's the notation. So this is f parentheses I. So we say this is f of x. Okay, f of x. So you'll see that, you'll see g of x. So g of x. You'll see h of x. H of x. So basically what this is, let's just use f of x now, because we can use all these other ones. So if I said f of x is equal to 2x plus 3, this is a function, and basically what I'm saying is almost like saying y equals 2x plus 3. All right, so what you're going to do is you're going to be given something like this, f of 4. That doesn't mean f times 4, it means f, again, f of 4. So that x is equal to 4. That's what it's saying. So I take that 4, and wherever I see an x, I plug it in. That's all I do. So it's f of 4 equals 2, and then I put a 4 in for the x. So 2 times 4 plus 3. So I simplify that, it gives me 8 plus 3, which is 11. So f of 4 equals 11. Okay? Same function. Use the same function here. What if I said f of negative 3? Well, you plug in negative 3 when there's an x. So 2 times negative 3 plus 3. So that's equal to negative 6 plus 3, or negative 3. Okay, so f of negative 3 is negative 3. So it's very, very simple. You are literally plugging in the value after that f. So right here, you're plugging that 4 into wherever you see an x and simplifying. That's all you're doing. Okay, that's called function notation. And again, you can use so many different letters: f of x, g of x, h of x, b of x. There's so many different ones you can use. All right, so let's try a couple more here, but it's pretty simple. The key here is, I would say, is really using parentheses, math fans. Okay, so this is what I mean. If I have something like, let's do g of x is equal to 2x squared minus 5x plus 3. All right, so that's your function. All right, so what I'm going to do now is I'm going to say g, what's g of negative 3? That means you're going to put a negative 3 into wherever you see an x. You're just going to substitute a negative 3 in there. That's all you're going to do. It's just substituting it in. Okay, so I'm going to get 2 parentheses negative 3 squared minus 5 times negative 3 plus 3. Okay? So make sure you plug everything in. And again, I think using parentheses is really important. And this is actually a good example of where parentheses is handy. This guy right here. Because what happens if you type this in your calculator without using parentheses? By the way, you can type all this in your calculator and get an answer, which I kind of recommend. But if you type in negative 3 squared, you guys should know that. If I just literally type in negative 3 squared, it's going to give me negative 9, which actually is wrong. Because I'm really trying to do this. I'm really trying to square the negative 3. And negative 3 times negative 3 is positive 9. Okay, but if you don't put it in parentheses and you hit that squared, it's actually going to give you the wrong answer. And you don't want the wrong answer. Okay, so if I literally just try it now. Just try to type this in your whatever calculator you have. Type in 2 parentheses negative 3 close parentheses, hit squared or a little up arrow 2, whatever it is, minus 5 parentheses negative 3 plus 3. Okay, so I'm going to do it by hand, but if you type in your calculator, you're going to get the same thing. So really, you're going to get a 2 times negative 3 squared is 9, and then negative 5 times negative 3 is positive 15, and then plus 3. So you really get 18 plus 15 plus 3. Okay? And if you type all that in there, you should get 36. Okay? So try it in your calculator. And hopefully you get 36. Okay? Like I said, parentheses are really, 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 really important. Okay, let's try another kind of crazy one. Actually, before we even do a crazy one, I just want to review real quickly. If you have 0 over 5 versus 5 over 0, type in your calculator. Just type it in. So if you type in 0 divided by 5, you actually get 0. If you type in 5 divided by 0, you actually get an error on your calculator. Please don't tell me error. We call this undefined. And you guys have heard this before. Okay, undefined means first of all, you can't divide by 0. Let me explain why. The first problem here, math fans, what I'm saying is, hey, what times 5? So what times 5 equals 0? Well, what do I have to multiply 5 by to give me 0? Don't you guys agree 0 times 5 is 0? So that's why the answer is 0. The second one says almost the same question, but what times 0 equals 5? There's nothing you can multiply by 0 to give you 5. That's why, so there's nothing. That's why that is undefined. Okay, so how do you remember that? I always kind of tell the kids, if like undefined, under, right? If the 0 is under, then it's undefined. Okay, if it's on top, then it's 0. You can always test in your calculator by plugging it in, but 0 underneath means undefined because it's under it, and you can't just can't do that problem. Okay, so I just think that's a good thing to know here. Okay, so let's do kind of a crazier little problem here. Let's do g of x is equal to 2x squared minus 5x plus 1 over x squared minus 7x minus 3. Okay, so that's our function. Kind of a nasty little function, but no big deal. And then I'm going to say, what is g of negative 2? So what you're going to do is you're actually going to do the top separately, and then you're going to do the bottom separately. Right? And then you're going to have a fraction. Okay, that's the best way to do these problems. So I'm going to put a negative 2 in this, so it's going to be 2 parentheses and then negative 2 squared minus 5 times negative 2 plus 1. That's the top, and the bottom is going to be negative 2 squared minus 7 times negative 2 minus 3. So I'm going to do the top and the bottom completely separately, not do anything fancy. So basically I'm going to say negative, let's do this in a couple steps here. You can do this all in your calculator. Do the top part in the calculator first and then the bottom part next. Okay, that's fine. Come up with an answer. But I'm going to do it manually. So negative 2 squared is 4. 4 times 2 is 8. So I'm doing kind of skipping a step here. That's 8. This is plus 10 plus 1. That's the top. And the bottom is going to give me 4 plus 14 minus 3. Okay, so I combine the top. I get 19 on the top. And the bottom, I get 4 and 14 is 18, minus 3 is 15. And that is my final answer. Okay? You don't need to simplify anymore. Just, that's 19 over 15 is perfect. Okay? So, that's why it's pretty easy to do these problems, guys. You know, again, it's just substituting in, making sure you use lots of parentheses and use your calculator appropriately, and you're good to go. Remember, 0 over 5 is 0, and 5 over 0 is undefined. Okay? So that's it about functions, how to identify a function with points and with graphs, and then also function notation in general. All right? That's it, math fans. Have an outstanding day. Adios. Goodbye.